Hello everyone, I am Zulaikat Faima of CSC Cybersecurity Department, pursuing my education in Sri Venkateswara College of Engineering, Bangalore. I am here to talk about the topic pointer and double pointer in the subject data structure. So let's see the introduction to pointers and double pointers. Pointers are variables that stores the memory address of another variable. Pointer allow us to indirectly access and manipulate data in memory. Double pointers are also known as pointers to pointer that store the memory address of the pointer. Declaration and initialization of the pointer. Pointers are declared by using asterisk before the variable name. They must be initialized with the memory address or of a compatible variables. Dereferencing pointers. Dereferencing a pointer means accessing the value of all the memory address it points to. It is done by using asterisk open bracket close bracket operator before the pointer variable. Null pointer. A null pointer points to no memory address. It is commonly used to indicate that a pointer does not point to any valid object, example int integer. A null pointer is a pointer that does not point to any memory location. It represents an invalid memory location. When a null value is assigned to a pointer, then the pointer is considered as null pointer. We can see the example to the null pointer. Pointer arithmetic. Pointer can be incremented or decremented to access different memory locations. The amount of increment or decrement depends on the data type of the pointer in that is pointing to. For example, pointer plus plus that means move the pointer to the next memory location. Arrays and pointers. Arrays can be accessed using pointers. The name of an array is a pointer to the first element of the array. Example int array 5 uh, int. Pointers and functions. Pointers can be passed to a function as an argument. They allow function to modify variables outside their own scope. Example void modify value int. Here we can see many examples regarding to pointers and functions. Dynamic memory allocation. Dynamic memory allocation allows us to allocate memory at runtime. It is done using the malloc or new functions. Example integer. Programmers use dynamic memory allocators such as malloc to acquire VM at runtime. For data structure whose size is only known at runtime, dynamic memory allocators manage an area of process virtual memory known as heap. Memory leaks. Memory leaks occurs when dynamically allocated memory is not properly deallocated. It can result in the loss of available memory over time. Properly freeing allocated memory using free or delete is essential. We can see memory leak happens here where unreferenced object and reference object are there. Double pointers. Double pointers are the pointers store memory address of another pointer. They are used to indirectly access and modify the pointers. Example int. Passing double pointers to the functions. Double pointer can be passed to the functions to modify the original pointers. Changes made to double pointer inside the function will reflect outside the function. Example void modify pointer open bracket int. Dynamic memory allocation with double pointers. Double pointers can be used for dynamic memory allocation of multi-dimensional arrays or structures. They provide flexible in allocating memory for complex data structures. Example int. Common mistakes that happens with the pointers. Dereferencing initialized pointers can lead to undefined behavior. Forgetting to free dynamically allocated memory can result in the memory leaks. Not checking for null pointers before dereferencing can lead to the crashes. Speech balloon pointers should go to the head, not into the mouth. This is the main example or for the mistakes that happens with the pointers. This is the quote. Advantages of the pointers. Pointers allow for efficient memory usage by avoiding unnecessary data copying. They enable dynamic memory allocation, leading to flexibility in program design. Pointers provide powerful tools for manipulating complex data structures. Benefits of pointer. Pointer allows C to support DMA. Pointer provides an efficient tool for manipulating dynamic data structures such as structures, linked list, trees. Example, pointers reduce length and complexity program. They increase execution speed and thus reduce the program execution time. Disadvantages of the pointers. Improper use of pointer can result in memory leaks and crashes. Pointers can make code harder to read and understand. They require careful memory management to avoid bugs. Dangling pointers. A dangling pointer is a null pointer that points to unallocated memory. Dereferencing a dangling pointer may cause the program to crash. It is impossible to test a pointer to see if it is dangling. Always set pointer to null if they do not point to allocated memory. Dangling pointer must always be avoided. Best practices with pointer. Always initialize pointers before using them. Check for null pointer before dereferencing them. Free dynamically allocated memory when it is no longer needed. Real world applications of pointer. Pointers are widely used in low level programming language like C and C++. They are essential for system programming device, drivers and embedded systems. Pointers are also crucial in data structures and algorithms. I conclude this topic by saying pointer and double pointer are powerful tool in programming. They allow for efficient memory management and manipulation. Understanding their proper use and best practices is essential for writing robust and efficient code. Thank you.